So here the division of charge, earlier there was capacitor, no? In place of that capacitor here, 6-volt cell I brought it, small change. Don't expect something very big numericals in the exam, something small change. We did same problem with one capacitor there. Now I brought a cell. Slight conditions will change, that's all. So it's asking to get the charge in all the capacitors. So let's go for division of charge because some concept we'll try to learn. So here the charge, let it be Q1 minus Q1. Let the charge here be Q2 minus Q2. So our question is find charge in all capacitors. Assume that no initial charge across capacitors. No, what about the charges in other? Here I'll assume let it be Q3 minus Q3, here Q4 minus Q4. So charge of isolated junction. So there's isolated junction, no? So the charge must be conserved. We can't write. So what is isolated junction? This everything will become isolated junction. I'm rounding off something here. You can see that one. This is isolated junction, no? But sir, cell is there, no problem. Nothing to do with that one. Initially, there no charge in the capacitor. Finally, also there should not be any charge. So what is the first equation? You can write it here: minus Q1 minus Q2. Initially, there was no charge. 0 should be equal to minus Q1 minus Q2 plus Q3 plus Q4. So therefore, Q1 plus Q2 is equal to Q3 plus Q4. Got the idea, no? This is the method. Earlier there was no charge. Now finally this is a charge. All 4 plates you have to bring at a time here. So write the loop equation. 4 equations, 4 unknowns. Solving will be the required answer. This will be 22 plus 22 minus Q1 by 8 minus Q4 by 10 equal to 0. Then 22 minus Q2 by 3 minus Q3 by 4 equal to 0. Then one loop equation here. Q1, Q2. This will be minus Q2 by 3 minus 6 plus Q1 by 8 equal to 0. One more here, there's a loop. Minus Q3 by 4, Q4 by 10 plus 6 equal to 0. Superposition principle, yes, you can apply it, but it will be lengthy. Will be lengthy. So solving these equations.
So minus Q2 by 3, sir.
Minus Q2 by 3. Yeah. Let me check where I am.
Minus Q2 by 3 minus 6 plus Q1 by 8 equal to 2.
Minus Q2 by 3. Okay, this one. This one, no? Minus Q2 by 3 minus
Yes,
6
sir.
plus Q1 by 8. Okay, yeah. So these are the equations 2, 3, 4, and 5. Can we solve by nodal analysis? No. Here, what is the charge is conserved? What charge is conserved here? Somebody like, okay, that conservation of charge is asking. Altogether, charge at isolated junction is 0, no? That only applied it.
Sir, can you tell how did we get that minus Q1 minus Q2
That one,
plus Q3?
okay. Before there was no charge here. 0, 0, 0, 0. Okay, fine. Finally, what you are having? Minus Q1, minus Q2, plus Q3, plus Q4. The charge of this green color I shaded, that much of charge should be conserved. Is it okay? The charge of 4 plates, at a time you have to take it, not pair of plates. Got it, no? So here I just brought this intentionally, this 4 plates, so you should be clear, and one battery also I just included here. And now can we solve by nodal analysis this one? Because this is something, so many equations. Nodal analysis, can we do it?
No.
We know potential, no? This will be 6 volt, I'll write. This will be 0 volt. And this potential difference, I'll write X. This also X, this is Y. X minus Y should be 22. Let me write what's wrong. Let's see. Eight, 3, 10, 4. 8 farad, 10 farad, 4 farad, 22 volt, 6 volt. No. Straight away, if you want, you can take this is 0 volt, or you can take this is 0 volt. So you took here, so somebody took this is 0, somebody took this is 0, all will get same answer. No, the potential difference, this should be 22 volt, no? So I'll write this is 22 plus X, this will be X. Justify. This should be the X. Why it should be 22 plus X here? Because the potential difference should be 22. Again, you should not write, sir, I'll want problem, I'll make it very simple. No, this is not correct, no? So just I want answer in very simple steps, I'll write it. You can't say this is 0, this is 0, not possible, no? This one, so it's not just writing some symbols here. Try to understand. You have to take help of a cell. This is X. And this is a Y, no? So this will be X. And this should be again 22 plus X. And this should be 6 volt. Okay, right now, the basic equation. But how do we have to conserve charge? Charge of what? Did about potential. So I charge at isolation junction should be conserved, no? So what charge here it enters, that much of charge should live here. That's the basic idea, no? What charge that enters here, that much what pen should live here. Okay, clear this. So again, if you write all the thing, that will be better. This will be more, little bit complex here. So some cases, the nodal analysis what pen will trouble us. It will lead to a lot of mathematics here. So here what happened? So what charge entered here, that much of charge should live. So what is the charge here again now? So this will be, you're going to divide Q1, Q2. You see what is Q1? You're going to write Q2, and this is Q. Then Q3, Q4. It's same, no? Like just now what we discussed. In fact, that is better rather than this is now more complicated. Again, you should be very good in distribution of charge. Already you have done the same thing earlier. So here what you should write, Q1 plus Q2 should be equal to Q3 plus Q4. Q equal to Q1 plus Q2. So here it will be Q equal to Q1 plus Q2. Then Q3 plus Q4, equating these two. Now define Q3, Q4, all that one. So what is Q1? 22 plus X minus 0 into 8. What is Q2? 22 plus X minus 6 into 3. Q3 also you write it. 0 minus X into 10. 6 minus X. So let me write the equation. Nothing wrong. You can experiment things. Q3 should be equal to 0 minus X into 10. So what is the only thing unknown is X. Solving it, I think you can avoid mathematics, but you should be very careful about these equations. X is only anything, solve it, you'll get the value of X. Cross verify both, you'll get the same answer. After getting value of X, then you can calculate the charges. Okay, no, so I'll upload some questions based on this chart distribution. Either